So, today's topic, I told I will try to solve numerical. Okay. Today we will do this numerical on histogram equalization. Okay. Today I intend to do histogram equalization. Next class I want to do histogram mapping. Okay. Can you listen? Somebody message me. Shashank, can you listen to me? Person. Okay. Thank you. Hmm? Okay. So now listen carefully. Okay. Sort of confusing, but you should know what's going on and why is it so. Observe the formula carefully. Hmm? One problem we will do. Okay. One numerical we will do. So, histogram equalization. So, yesterday we had this brief introduction to, you can see my screen, right? The PDF. Wait, let me make it full screen. Yeah, you can see, right? Okay. Hmm. So, both the things. So, what is this histogram, by the way? Histogram gives you the overall impression of an image. So, if at all you want to enhance an image, make it look brighter, make it look, image with more contrast or something, then histogram is the preferred tool. Okay. Histogram is the preferred tool. Okay, which you will be using most of the times. Okay. So what's the catch? What do we do, by the way? You have a very poor histogram. What is histogram equalization? We had seen it, right? What histogram equalization does, it images can be sometimes lying on the having an histogram lying on extreme left side. Sometimes they may be on extreme right. Sometimes they may be concentrated in the center. So you try to somehow make sure that they are equally distributed. Okay. By doing these things automatically, you are trying to see a formula, trying to derive a formula which can do these things automatically. Now derivation is in the textbooks. I'm not going to get into that. Let us see what author had to say. Okay, so author starts with this particular relation of the output image. Author says that if at all you can get an image, which can, okay, the output processed image can be given as input image. Okay, the PDF. Okay, probability distribution function. Okay, probability distribution function. This is a continuous case. Author is taking a continuous intensity case. He relates the output image probability with the input image PDF with this rate of change of both respect to each other. Okay, that's what it does. He does it by some method. Okay. So when you do this sort of theory in PPT, it kind of gets boring. Anyway, author has taken the continuous time thing and he has tried to explain it. And as per author, at the end of the entire affair, we should have my PDF from source to destination. You should have a PDF which would be maybe something like this, whatever it is, something like this should look flat. Okay. That's what it should be. So these kind of PDFs, which will have constant amplitude from extreme left to the right, is called as a uniform PDF. That's what author aims. And in the process from the previous equation, which was something like this, author relates this particular expression with this one. Okay, author, you can see here ds by dr. This is dr by ds. The change in the output with respect to change in the input. That's what he has taken. Okay, what is equalization? Do you know what is meant by equalization, by the way? We remember the word equalization from our digital communication. There was this concept, remember. Now I am trying to tell you what this thing is all about. Okay. You remember there was this communication channel, right? There was input X. You put it on a communication channel. The channel will have an impulse response H maybe, and then you will get output Y. Okay. their Fourier transform would be y is equal to x into h. Remember, y is equal to x into h, where x and h are the Fourier transforms of input and the channel behavior. Now, from this is we want to recover our input, right? We want to recover the input. Now, this h determines if this h is 1, then my input will straight away go to output. Unfortunately, it is not so. So what I have to do to nullify the effect, I need to pass this thing, whatever y, I need to pass this thing through one more block, which may have a response 1 divided by capital H, remember, not small h, the Fourier, okay. 1 divided by capital H. If you do so, then you will be able to get the original thing back. Remember. So here our task is, so when you do that, my effect of this particular thing is simply nullified. Okay, that's the idea. Now here also it is the same problem. If at all you want this particular entire intensity to have a uniform distribution, which is 1 by 1 divided by L minus 1, you want it to have a uniform distribution, then what you have to do, is you should relate, there is this particular change in the changes in the input intensities, which is sort of spurious. If at all you somehow nullify the effect by dividing them with a normalized one, okay, by their impact, probably you can have a PDF, something like this, a uniform PDF. Okay, this is all a theoretical thing, doesn't actually work. Maybe it works for continuous time, but author tries to draw a parallel between this continuous time and discrete time, and the all integrations have become summation. Integrations have become summation, and there is a formula. Okay, now again, as I told you, I will not get much into the formula. I will not get much into the derivation of formula. Rather, let's keep it simple. And I would like to tell you the end formula, what it is. Okay, so so the output intensity is now shall be given by, there is this formula. What is this? L minus 1. Now say if at all I have colors from 258-bit image, then L is 256. Okay, 2 to the power 8. 256 minus 1 divided by m into n, divided by m into n. Suppose my image is say 640 into 480 image. Suppose my image is 640 cross 480, then m cross n would be 648 into 480. Okay, simple multiplication. What is this thing? Now these here nj are the cumulative probabilities accumulated. Okay, cumulative probabilities accumulated. Okay, what we'll do, rather than concentrating in this one, let us keep this formula. This is better. This formula is better. So this is a cumulative sum of the individual intensity probabilities. Okay, cumulative sum of individual intensity probabilities. At first intensity level, it is the first intensity probability. What is meant by the probability? Probability, when I say the maximum value shall be less than or equal to 1 only. Okay, oh god, it's, I'm confusing you once again. Let us go to the problem. Okay, let's go to a numerical. Let's go to a numerical. Okay, here is a numerical. Let us see what is the catch in one. Now what you do is, we are doing this exercise that we want everybody's attendance. Okay, so what you do, everybody just um, type in hi in the comment section, nothing else. Okay. Simply type hi in the comments. Okay, everybody type hi. So if it all do something in the comment section, we will record it as your attendance. Okay. You have a better method calling your roll numbers. No, no, simply everybody type a hi. Okay. Okay, let's do that. Okay, yeah, there they are. Okay. Everybody just type in. Okay. Okay, now let us start. Okay, so now here is an image. Here is an image. Listen carefully. Here is an image. What will be given in the input as a part of, it's a 3-bit image. When somebody says a 3-bit image, when somebody says a 3-bit image, then automatically the number of levels L shall be assumed as 2 to the power 3. When somebody says 8-bit image, L shall be taken as 2 to the power 8. Okay. 4-bit image. Okay, usually images will be mentioned not in the number of levels but in number of bits. From that L shall be derived 2 to the power bits, what should I say. Then size will be given, and M cross N will be given. 64 cross 64, M is 64, N is also 64. And usually you will be provided with the intensities. Usually you will be provided with the histogram. Usually you will be provided with the histogram, and then you have to proceed further. Now what does this histogram mean? Now there are 8 intensity levels. Intensity 0 to intensity 7. 0 is for black, 7 is for white. Okay, everybody listening, right? 0 is for black, 1 is a dark gray, 2 is mid gray, then there is light gray, then there is pale gray, then there is silver gray, and finally it is white. Okay. What this particular thing? Then what this nk, what does this nk indicate? This nk indicates that there are 790 pixels. There are 790 pixels of intensity 0, that is black. There are 81 pixels which are white. There are 1023 pixels that are of dark gray. What this thing? Getting? Now say, let me do this small exercise. Let me also take an image. Let me take an image. Okay. It's a very small image. What shall I take? 1 2 3. Oh, it's getting boring, too many lines. Let me try. Wait, let me go for a smaller one. Okay. Let me go for a smaller image. Okay, say that is my image. Let me call it a 4 cross 4 image. Let me have a 4 cross 4 image. What I want to do, I will fill it in with this with certain numbers. You should tell me what is the histogram of it. Okay. You should tell me what is the histogram. Let me fill in with numbers. What sort of image shall I take? I will take a 2-bit image. Let me take a 2-bit image. Okay. Let me take a 4 cross 4. Let me take a 4 cross 4 2-bit image. Okay. 0 1 1 0 2 3 1 0 2 0 0 0 0 0 1 2. I have now drawn an image. Now can you tell me the histogram of this image? Can you tell me the histogram of this particular image? Somebody tell me the histogram of this particular image. This is my image. Somebody tell me the histogram just to have a feel of it. Okay. What does my x-axis contain? What does my x-axis contain in this particular image? What does my x-axis contain? 0 1 2 3. Very good, Darshan. X-axis contains 0 1. This is so ITC, right? Whatever we have studied earlier. X-axis contains 0 1 2 3. Okay. Now what will be the value at 0? What will be the value at 1? What will be the value at 2? What will be the value at 3? Can somebody tell me? Darshan's quota is over. Somebody tell me the value at 0. As I told you, Darshan. Oh, it's for everyone. Okay, okay. 0 is, yeah, 1 2 3 4 5 6 7 8. Okay. There are 8 zeros. Okay, there are 8 zeros. Okay, what about 1? What about 1? Somebody, somebody, what will be the value amplitude at 1? Can somebody ping? Other than Darshan, somebody. Value at 1, value at 2, and value at 3. Somebody? Hmm? Please be curious and give it a try. Okay, okay. How many? Yes, Abhishek. 1, 2, 3, 4. Very good. Okay. So there are four, four ones. Okay. Oh, this is so high school mathematics, right? Okay, okay. So, yeah. Now, what about 2? 2 somebody? Vinod, yes. Value of 1 is 4. Very good. Okay. Very good. 4. Yeah. What about 2? What is there at 2? 3. Yes. Very good. Okay. At 2 there is 3. Then at 3, at 3, what will be there at 3? Hmm? Somebody at 3? Vinod at 3? Am I audible? Everyone? Yeah. At 3 it is 1. Very good. At 3 it is 1. So there I have. There I have. So what are the properties of a histogram? If at all I add this 8 plus 4 plus 3 plus 1, 12, 13, 14, 15, 16. If at all I add all these amplitudes, okay. If I so in my particular case, I will have only 1, 2, 3, and 4, and nk the number of pixels shall be 8, 4, 3, and 1. Okay, it will be 8, 4, 3, and 1. Okay, now you can see you add all of them 8 plus 4 plus 3 plus 1. It is going to be 16, which is 4 multiplied by 4. Okay, and what will be the probabilities? Now see, how do we get the probability? 790 divided by 64 into 64. Okay, that is why 0.19, 0.25, 0.21, 0.16, so and so. Okay, can you tell me in our case what will be the probability? Now are you getting what is the difference between a histogram and a PDF, probability distribution function? Now can you tell me? So the first value will be 8 divided by 16. Second value will be 4 divided by 16. 3 divided by 16. Then a 1 divided by 16. Got this? Got this? Got this particular thing? Got this? So this is around 0.5. Okay, the second one is around 0.25 in our case. Okay, third one is difficult. You do this. Okay, 3 divided by 16 is difficult, I guess. So fourth one I will do. It's 1 by 16. 1 by 16 is how much? That also is difficult. Okay. Okay. What this particular thing? Are you getting the feel of it? Okay. Shall we continue? So now, so now, hmm, so now, what should we do? What next? So first what we'll do is now we will go for cumulative. Now I will rub this thing. Okay. I hope you remember the value. So what is it by the way? 8, 4, 3, and 1. Let me write it down somewhere on my sheet. Okay. 8, 4. Yeah. Anything? Anything? Sushma, you have any query? 8, 4, 3, and 1 are my intensities. 8, 4, 3, and 1 are my intensities. Okay. So now I will rub this thing. Okay. Now let us go back. Now you got this particular thing. What are these probabilities? What are these probabilities? So this number 0.02 is what? This is 81 divided by 64 multiplied. What is 64 multiplied by 64? I don't know, 3600 something more than that. Okay. That's the number. Now what we will do is we will do the cumulative addition. What is this cumulative addition? You see the formula here. Let me go back to the previous page. What is this? This is cumulative addition. First value will be the probability itself. Second value, second intensity, second value will be probability of the 0th level and probability of the first level. Third value will be probability of zeros plus probability of first plus probability of second plus probability of third. multiplied by their levels L minus 1. Okay, remember the formula. See, this is cumulative sum. At 0 it is first value, at 1 zeroth value plus 1 value, at 2 it is 0 plus first plus second value. Okay, zeroth, is it a term? Okay, 0th plus first plus second value, everything shall be multiplied by 255. Okay, everything shall be multiplied by 255. Okay, now so what just happened? What just happened? Now do you know, right, the first value? How do we get this first value? This is 0.19, 0.19 multiplied by 255. Okay, 0.19 multiplied by 255. I told it wrong, right? Nobody disagreed with me. Okay, I have been telling it the wrong way all the while. Hmm? L is 8, sorry. Hmm? L is 8. Okay. Hmm? L is 8. Okay. So 0.19 into 8 is 1.33. What is this one, by the way? What is this number? This number S1 is got by what? This is 0.19, 0.19 plus the next intensity, right? S1 is 0th intensity plus first intensity, 0.25, 0.25. Now this thing multiplied by 8 or 7. Somebody multiplied by 8 or 7, multiplied by 7. There is a usual mistake everybody makes. L is equal to 8. L is equal to 8, but this shall be multiplied by 7. Okay. Then what about the third one? What about the third one? What about this one? It is 0.9. Okay. Third one is 0.9 plus 0.25 plus 0.23 multiplied by 7. Okay. Okay. So and so. Now what we do is, once you are done with this, now round intensity value to nearest integer. Now round intensity value to nearest integer. So 1.33. See, this is not rounding to the next value. This is not the way we calculate your internal marks. Okay. This is, if at all it is below 1.5, it is 1. If it is above 6.65, it is 7. Okay, you round this thing. Now what happens? Once you are done with this, the next task is, once you are done with this, next task is the mapping. Okay, next task is the mapping. Now S0, you can see we got the value 1.33 and that was rounded to 1. What that means is, all the intensities, all those pixels, all those 719 pixels, which earlier had the intensity 0, dark, now shall be replaced by 1, which is light gray. Sorry, dark gray. Got this particular? Now this particular stick here, all 709 pixels, which were earlier had a pixel value 0, now shall be replaced by pixel intensity 1. Okay, got this particular thing? So got it. Now what is this S1 pointing to 3? What does that mean? S1 pointing to 3, what does that mean? All those 1023 pixels which earlier had the pixel intensity 1, now shall be replaced by pixel intensity 3, so that this entire stick will now be placed in 3. Okay. Got it. Somebody, anybody, doubts? Okay. And S2 is equal to 5. S2 is equal to 5. This means all those pixel intensities in the dark gray now shall be put here. You can see this thing has been moved here. Now there is an interesting one. You can see S3 also we got the value 6. S4 also we got the value 6. So all the pixel intensities, all these pixels, 656 pixels with intensity 3, 329 pixels with intensity 4. Those shall be replaced by this pixel with intensity 6. Okay, so this plus this, these two, the intensity, those pixels with intensity 3 and 4, all the pixels now shall be replaced by pixel intensity 6. So all those dark pixels will simply now become a silver gray, light gray. And then those with intensity 5, 6 and 7, all those pixels shall be replaced by a white. Okay, shall be replaced by white. Now got this particular thing, got the particular thing. Now let me ask you, what just happened? What just happened? So this is the original histogram PR of R. Now this is the, not the histogram, this is not the histogram, this is probability distribution function. You multiply this each value with 64 cross 64, then you will get your histogram. Okay, for the timing, this is my probability distribution function only. Now please tell me, somebody please tell me, this was the original histogram. What is the problem with this? This is the resulting histogram. What is the advantage of this? Can somebody tell me what has just happened? What has just happened? Yeah, equalizing. Yeah, the thing has equalized. So what has happened? What was the deal? What was the problem with the first histogram? How was it, by the way? Can you tell me this histogram, this particular image with these details? It was a darker image. Very good. It had all the intensities concentrated on the left side. It was a darker image. And now you have done this equalization, and the image has turned out into be somewhat balanced. I don't say equal, but somewhat balanced. Okay, somewhat balanced. That's that. Okay, that is histogram equalization. Okay, that is histogram equalization. Now shall we take our example now? I forgot that particular image. I forgot that particular image. You can see the image which I took had intensities 8, 4, 3 and 1. Even that particular image was something like a darker image only. Okay, it was also something like darker image only. Now you should somehow make it I should say, I don't know, brighter image. Okay, so the equalization would help. Got this particular thing? I hope there is no confusion as such. I hope there is no confusion as such. Okay, what is particular? That's what equalization does. Now thank God there is MATLAB, and everything is sort of easy in MATLAB. Okay, so in our example, whatever I have 8431, let us do that in MATLAB. Okay, let's not do this on papers. Let's do this on paper. Anybody doubts? Anybody doubts? So what just the formula? So it was all done with respect to that particular formula. Here you can see everything. This is as per the formula only. This has been done clearly as per the formula. Okay, and then there was equalization formula where here. So this one PR, which one? This one. This was part of your pixel intensity, cumulative intensity divided by m divided by n was there. You multiplied by L minus 1, just map, and there you could get it. Okay, now there is some time remaining. Let me share with you the MATLAB thing. Okay, let me share with you the MATLAB thing. Hmm? Where MATLAB? Okay, not here. Let me open MATLAB. Okay, give us some time. Be there. Okay. Hmm. Okay, by the time it loads, now let us see what is the next task that we have. Next task that we have is till MATLAB loads. Okay. Next task we have is, can you listen? Are you there? Hmm. Next task what we have is histogram matching. Okay, so histogram equalization, there was nothing like a customization or something. We simply equalized. Okay, so the next thing what you can do is we can define what sort of histogram can should our image have. Okay, specific location in, that's what provides us this power to set the contrast and all. When you want to increase the contrast, it cannot be done by simply equalizing the image. For making a high contrast image, you should move most pixels on the left side and few of them on the extreme right side. Okay. Now let MATLAB load here. Okay, let MATLAB load, then we can quickly. Hmm. So, did you see that particular book, textbook, which I had shared with you? Which is that? One is your textbook. Okay. So, what I want you all to do, so you're there, right? You can listen to me. Somebody ping, it's so scary. Somebody ping me. Abhishek, can you listen to me? Okay, okay. So what I wanted to do is just to know how cool inventions have come recently. I want you to install Acrobat, the new Acrobat DC. Okay, Acrobat DC. It will give you 1 month free use. Okay, and see the textbook, digital image processing, second edition, worst copy. Okay, very poorly scanned thing. But once you put it in Acrobat DC, Acrobat DC, makes all those text whatever that comes in, right, into as if it were a digitally generated document. Just observe. Then it would also let you copy the text. It will also let you copy the text. Okay, just for that experience, just download that book and install Acrobat DC. You have that new Acrobat with you, Adobe. Hmm? Please download and give it a try. Download and give it a try. Second thing I want you to do is, there are so many functions there in that particular second textbook that I have shared. It's a reference, I don't know, same author, commands. Okay, it has so many MATLAB commands. Okay. That you, what you can do is, you can there also you can do so many things. Okay, there also you can do so many things. Okay, now, so Darshan, just message me something. Just message. So those who had not didn't say hi, just type in a hi. It's a way of um, maintaining attendance for me. Okay. Your all chats will be recorded. Okay. So please type a hi there. Okay. And since I changed my PC time here for some reason, what happens is, I don't know when the class will stop. Okay. Anyway, let me have an image. Okay. Im is equal to, let me have an image. What is that? 0, 0, 0, 1, uh, 0, uh, 1, 0, 210, and 1 2 3 4, 0 0, 3, uh, 1. Then suggest me the fourth number, 0 0 1 0 5 6, another two zeros. I think 1 2 3 4 5 6 7 8. Okay. Some other number, 1 2 2, one more 2 I can put, I think. Okay. 2 2 2, 1 1 1. Okay, 1. Okay. There is my image. Okay, there is my image. Okay, so I am I am hist of image. Have I shared with you my MATLAB? No, right? Oh god. MATLAB. Okay, okay. Yeah, sorry. Okay, so there is the histogram of that. Don't know whether it will come or not because MATLAB screen. Yeah, sorry. Hmm. So I did that histogram. It's 4 cross 4 double. Okay, the data I did not. I should have converted the data type there. Hmm. So the histogram, it has not popped up. Okay, wait a second. Double, right? Mm, okay. There I have histogram. Okay, this particular thing. Okay, histogram. Let me use histogram. Let me use this command because the data type, it's not an image. Okay, that's why I'm going for the command histogram. Okay, there I have the histogram. Now can you see this histogram here? Okay, I used im histos only for images where data type is unsigned integer. Okay, histogram is for any kind of data. Now there I have my histogram. Now let me equalize this particular thing. Okay, let me equalize this thing. Okay, uh, HIST. So let me some name HISTEQ is the command. HIST is the command. This should be applied on histogram of the image, image which I took. Hmm? Let us see what happens. You're still there, right? Okay, the moment it loads, I will display it. By then I think the class will stop also. I don't know. Hmm? If it stops, I will just okay, okay, okay. What happened? Wait a second. Okay. Hmm. Yeah, yeah. I got an error here. Wait a second. Let me. So some variable. Let me put that histogram. Histogram of IM. Let me copy that to histogram. RT. It's a histogram. Okay. So now WER is equal to of what are those values? 8, 4, 3, 1. Okay, okay. Screen. Okay, sorry, sorry, sorry. Yeah, there we are. Okay, so equalization. So I am not. What happened? Got some glitch there. Okay. Expected numbers to be of unsigned integer. Okay. Uh, Evaluate selection. Wait a second. Be there. You have seen the original image, right? How its histogram was like. Copy.